Bismillahirrahmanirrahim. In today's lecture, we will solve an example 6-2. In 6-2, we are given that a 480 volt, 60 hertz, and 50 horsepower three-phase induction motor is drawing 60 ampere of current at a lagging power factor of 0.85. The stator copper losses are 2 kilowatt. The rotor copper losses are 100 watt. 700 watt. The friction and windage losses are 600 watt. The core losses are 1800 watt and the stray losses are negligible. We have to find the air gap power, the power converted, and the output power, and also the efficiency of the motor. So first of all, we have to write all the given data, and then we have to solve the find out the required. So first of all, we have to write all the given data. We are given that its voltage is 480 volts. It is operating on 60 hertz frequency. Its power is 50 horsepower. It is a three-phase induction motor and it is drawing 60 ampere of current with a power factor of 0.85 lagging. The stator copper losses, the power losses is stator copper loss is 2 kilowatt. The rotor copper losses, the power losses is rotor copper losses. It is 700 watt. The power losses is a friction plus windage. It is 1800. It is 600 watt. And the core losses are actually 1800 watts. We have to find number first. We have to find the air gap power. So now refer to the power flow diagram. यहाँ पावर फ्लो डायग्राम में आप देखें तो your air gap power is actually the input power minus the stator copper losses minus core losses. So अगर आप input power से stator copper losses core losses को minus करें तो you will get the air gap power. So we know that the air gap power is actually the input power minus the stator copper losses minus the core loss. So input power is actually under root 3 times Vi cos theta. So it is under root 3 times 480. Current is 60 ampere. Power factor is 0.85. So multiplying all these, we will get 42.4 kilowatt. So this is actually the input power. Now subtracting, we have to find the air gap power. So the air gap power is the input power, which is 42.4 kilowatt, minus the stator copper loss. The stator copper loss is 2 kilowatt, minus the core loss, which is 1800 watt. So calculating this, we will get the air gap power 38.6 kilowatt. So this is the air gap power. In part B, we have to find the power converted. So in part B, we have to find the power converted. So now again refer to the power flow diagram. So this is the power converted. So the power converted is actually the air gap power minus the rotor copper loss. So when you subtract the rotor copper loss from the air gap loss, you will get the power converted. So power converted is actually the air gap power minus the power at the rotor copper loss. So we have calculated, it comes out 38.6 kilowatt minus the power dissipated as a rotor copper loss. This is given as 700 watt. So we will get calculating this, we will get 37.9 kilowatt. This is the power converted. In part C, we have to calculate the output power. Again, refer to the power flow diagram. The output power is the power converted minus the friction and windage losses minus stray losses is actually the output power. So here in part C, the output power is equal to the converted power minus the power at friction and windage loss minus the stray losses. So power converted, we have find it comes out 37.9 kilowatt. The power dissipated as friction and windage losses is given as 600 watt, and the stray losses are negligible. So the output power comes out as 37.3 kilowatt. Now in part D, we are asked about to find the efficiency. The efficiency of this motor is the output power divided by input power into 100%. So the output power is given, we have find the output power, that is 37.3 kilowatt. The input power is 42.4 kilowatt. We have calculated these two powers into 100%. So the answer is 88%. This is the efficiency of this motor. So this was all about this numerical problem.